Hello students, so today I am going to cover the data science for CBSE grade 9 students, right. Now, you must remember that data science in CBSE is a part of skill education, just like another important topic artificial intelligence is. Okay. Now, you see I have already uploaded two very important videos on this data science for class 9, and the first video is on chapter 1 and the second video is on chapter 2. You can find the link in the description box. Okay. And also there are two videos for class 6 maths, where I have basically talked about what is data, classifying data, and then graphs. Basically, this is all there is to it, mainly data visualization. So, this I have already covered in these two separate videos. You can take a look over there. Okay. Now, with this, let us start with today's topic for class 9. So, the very first chapter is basically introduction to data, and now here you will learn not only about data, but also about information, and then the DIKW model, how data influence our lives, what are data footprints, and then the tragedy involved, data loss and again recovery. So, first of all, data. Well, whatever you read, write, speak, observe, basically even the audio and the video, everything is data. Okay. Now, every day we share so much data when we read, write, speak and watch. Now, it can be numbers, letters, alphabets, or a combination of all this. Now, data can be defined as again facts or information which when stored can be used as a basis for decision making, calculation or discussion. Now, what about information? You see data, okay, data can be number, symbol or text which may not mean anything to individuals on its own. However, when data is processed and put in context, they bear a meaning, and this meaningful data is basically information, because it can be used for decision making, calculations as well as discussions. See, so raw data which do not have any meaning on its own, raw facts. So, this is basically your data. And what is information? Basically, it is the transformed or organized data which when presented in a context is useful. So, basically you see data after transformation to information can also be converted to knowledge and next to wisdom. So, basically these are transformations. So, data to information, next information to knowledge, next transformation is knowledge to wisdom. So, here we have 3 level of transformations, and this is what DIKW stands for. So, basically DIKW means data to information, and then information to knowledge, and then knowledge to wisdom model. Okay. So, how data influence our lives? You see, data heavily influence our daily lives. Now, starting from online shopping to watching your favorite shows on the television, to again ordering food to the best restaurants, data is very important. You see, how do you know this restaurant is good? You use an online app and there you look into the reviews. So, basically those reviews are given by individuals who have their own experiences. So, they are sharing their own data with you through the app, and using their data you are able to find your best restaurant. Okay. So, see, data and data analysis. So, this best restaurant is a result of data collection as well as data analysis. But this is not done by you, this is done by a silent algorithm utilized by the app itself, the app which you are using to find your best restaurant. Now, data and data analysis have a significant impact on our lives. I have just given you one example. Now, few aspects of our life that are impacted by data are healthcare, online shopping, education, travel, online shows. Now, in this regard, this data footprint is very important. What is that? You see, in our daily life, during any digital transaction, digital interaction, okay, the internet will leave some of our data, and that is the data footprint. See, say for example, you see, in our daily life, the internet has become an essential part. With all the activities we do on the internet, we create trails of data. These trails of data are called data footprint. See, this person over here, he has walked from here, he is walking over there. So, this is basically example of people's footprints. So, people are moving from one point to another point, okay, and say footprint is over there. And similarly, when we go and do a internet search, from there we go to some other web page and do some search, again we go to some other page, we do some search, and so on. So, this whole thing is just a data footprint, just like a person's footprint when they are walking over there. Okay. So, basically this is not a physical footprint, but a digital footprint. Okay. See, digital footprint that can be used to identify as individuals. Okay. Now, this image shows how we connect to the rest of the world and the people around us, this one. Now, you see, data can be lost, corrupted and damaged, even deleted due to multiple reasons like transaction failure, system crash, disk failure, hard disk failure, right. So, effectively hardware issue as well as software issue. Now, the process of restoring inaccessible, lost or corrupted, damaged or deleted data is called data recovery. To prevent data loss, we should frequently back up our data. You see, large enterprise systems generally use backup data storage, where they recover the data in the case of loss. So, say for example, there is a building where data is kept, okay, and people are doing the analysis, but unfortunately the building, there is fire in the building, then everything is lost. However, there is yet another building where all the data is regular on a regular basis, it is being saved. So, if there is some problem with this building, then the data is safe at least. Okay. Well, the next chapter is regarding arranging and collecting data. So, now we will talk about data collection, variable, data sources, big data, and then ask relevant questions as well as talk about univariate and multivariate data. So, first of all, what is data collection? Now, you see, the method of gathering data for calculating and analyzing reliable insights, that is meaningful results, is known as data collection, and this is done using standard validated techniques like survey. For example, you see, a researcher or scientist works based on the collected data. So, this collection has to be scientific, proper, organized. Now, data collection is the primary and essential step in most cases. Now, next we have variables, and what is that? Basically, variable is an attribute, characteristics or property of an object of study that may vary for different cases. Just in algebra, we have variable x whose value can change, right? It can take values 1, 2.2, anything. So, similarly, we have got variable over here as well in data science. So, which the variable basically, as the name suggests, it varies for different case studies in research. Now, we can have both numerical as well as categorical variable. What are numericals? As the name suggests, these variables are basically numbers. For example, they represent numbers. So, example is age, weight, height. What about categorical variable? These variables represent values that are words, for example, name, nationality, favorite sport and all that. Next, let us talk about types of data. Well, you see, data can be divided into two categories, quantitative and qualitative. Okay. Now, what is qualitative? Basically, it means that it cannot be expressed as a number. Again, it cannot be counted. So, what are the examples? Words, pictures, taste, smell. Okay. Now, what is quantitative? So, it is something which can be expressed as number. Since it is a number, definitely it can be counted. What are some examples? Definitely numbers and analysis, statistics. Okay. Next is types of data sources. Well, you see, we can have primary as well as secondary data sources. Now, what are primary? Primaries are basically, they can be through interviews, as I mentioned previously, online survey, marketing campaign, even feedback forms. You must have got some experience with at least one of them. And then we have got the secondary source. So, secondary means there is some already some data has been taken. Just a second. Secondary source means already some data has been taken, okay, and now we are going to reanalyze it for some further analysis, something like that. So, basically secondary source, transactional database, IoT sensor data, satellite data, web traffic, social media data, all that. Now, next is the big data. As the name suggests, the data is big. So, it can be crores and crores of rows and crores of column, which can change over time. So, it is very complicated. So, to do the analysis, we need extremely different type of approach compared to a normal statistical method. So, you see, basically when the data volumes exceed the processing capacities of traditional databases, they are known as big data. Now, millions of users are using the social media platforms like YouTube, Facebook, Twitter, X and so on, and as a result they are creating enormous amount of content every minute. So, as a sort of, you can say, estimate, 10 to the power 15 bytes of data is generated every day, single day on the entire earth. And then can you imagine, you get recommendations on your app, you get recommendations from your social media, and this is all because there is a silent algorithm which works on this much data and then figures out the pattern and then gives suggestions. So, think of it, such a complex system, but we have got algorithm to work on it. Mainly these are artificially intelligent algorithms. Now, so big data, effectively you can say that they are systems which can extract statistical insights from big amounts of data, and if such a system, what do we call? We call them big data systems. Understand? Now, one of the ways of finding a pattern is questioning your data, and you have to question, you got to have the right question, because depending on it you will have a different algorithm. So, you see, data is typically stored as numbers, numeric or labels, categories. Now, based on the type of data, we need to ask 5 simple questions from the data, which will basically give you 5 types of algorithms. What are they? First is binary classification. So, whether it is hot or cold, whether it is A or B. Next, anomaly detection. So, out of many things, which one is the odd one out? Next, regression algorithm. Basically, it will figure out number, how much or how many. Next, clustering algorithm. So, basically, you can cluster or group some of the data or entire data. After that, reinforcement algorithm, which will basically help you decide what to do next from your present scenario. Now again, we also have the data depending on whether it is univariate or multivariate. Now what is univariate? It is a type of data that has only one variable or which does not involve multiple parameters or relationships. So for example, the height of students is a univariate data. So see over here, this is the number of students, okay, and this is the height of students. So this is a univariate data. So only two axes. Okay. Now suppose I plot number of students over here in here, height of students, and then on the third axis should not be like this, third axis, okay. So basically yet another third axis x, y, z, and the third axis, let me find out the age. Then I will say that this is a multivariate data in this case. So number, age versus height, numbers versus age versus height. So example of multivariate data. So as you have seen, multivariate data is a type of data which involves relationship between multiple variables. This you will get in this plot. Okay. So number, age and height, something like this. So for example, sales of umbrella increases during the rainy season. Now we see umbrella sales are dependent on rainfall. However, there are two variables, one is rainfall and next is sales. Now this type of data are more complex than univariate, and they involve comparisons and relationships with multiple parameters. Okay. So next chapter is chapter 3, which is regarding data visualization. So let us now start with what is visualization first, then we will talk about data plotting, histogramming, uses of shape, and again uses of single and multivariate plots. Okay. Now importance of data visualization, you see, with so much information around us, it is definitely challenging to view the data and then find the pattern out of it. Okay. So for this we need data visualization, because this helps in easier pattern recognition, easier inference building. So representing data through visualization like graphs, charts, maps give us a visual context of the data, and this also makes complex data simple and enables our human mind to understand its significance, that is, find the pattern. So basically data visualization, this means now plotting. Now there can be different ways to visualize the data depending on the data being modeled and its purpose. Now different kinds of graphs and tables can be used to visualize the data. So basically, dear students, now we will talk about various types of plots and then the measures. So first is the dot plot. So basically dot plot is a graphical display, see, of data using dots. So how much minutes to reach school by A, B, C, D, E. Now these are just dots. So A takes 6 minutes, B takes 2 minutes, C takes 4 minutes, okay. And what about E? E takes between 4 to 6. So basically E takes 5 minutes. What about D? D takes 8 minutes. So from this you can easily say, hey, who takes the longest time to reach the school? Well, it's D. And who takes the shortest time to reach the school? It's A. So if you are told that out of all these students, someone is riding a bicycle, who can it be? Definitely it has to be B, because it reaches the school fastest. Yeah, there is a possibility that B can also go in a car or in a bus, but now given the scenario that all 5 of them are either going by bicycle or they walk, then only possibility for B is it goes by bicycle, since it takes the shortest time to reach the school. Now next is bar graph. So what's a bar graph? Basically a graphical display of data using bars, okay, like your chocolate candy that you used to have when you are younger, chocolate candy bars. Yes. So it's a graphical display of data using bars of different heights. See here, this signs basically students registered for classes. Now science, how many students are there? Approximately 27 students. For maths, approximately 32 students, and so on. So here the height corresponds to the number. What about Hindi? For Hindi it is approximately 44, and so on. So you can see the possible, you can see the plot of the graphs. Now here the plot is vertically, we can also have a horizontal plot like this. Now in a bar graph, the bars are presented to show elements so that they do not touch each other. See, there are gaps. Sorry. So there are gaps over here. Okay, so that the elements are sort of independent with each other. See another example. Now this is a horizontal graph, and the previous one was a vertical graph. This one. So see, remember we said that we can also have a horizontal graph. So this is the column chart. Now you see, in the data we can have maximum and minimum. See for example, this particular data here, D takes the maximum time, longest, and B takes the minimum time. So see, this is what you can say. So effectively we can say that in the data there is a structure like this. There is one maximum, there is one minimum, and more or less average results, something like this. So the minimum of the data is less than or equal to other values of our data set. Now if we had to call all our data, if we order basically all the data in ascending order, the first number in our list will be the minimum, and the last number will be the maximum, the largest one. Next is frequency. So frequency of a data value is the number of times the data value occurs or repeats. That's it, number of repetitions. So for example, if 5 students have a score of 85 in English, the score of 85 is said to have a frequency of 5. Okay, or we just say f equal to 5. F stands for frequency. Well, next is the concept of histogram, which is basically a graphical display of data, again using bars of different heights. It is used to summarize discrete as well as continuous data. So basically the histogram displays the number of data points that fall within a given set of values, which are known as bins, to provide visual representation of numerical data. However, note that unlike vertical graphs, a histogram shows no gaps. So basically histogram will look like this, no gap between the various bars. So this is a histogram. Okay. And what's a vertical graph? Bar graph was like this, that we have covered previously. So you see, students, we can have both single as well as multivariate plots. Remember the x, y, z axis, it was a multivariate plot. Now there is yet another example of multivariate plot. So company A, company B, company C, 3 companies over here, 3 companies shown by different colors. Okay, and 2 axis, here is the month, x axis is the month, and what's the y axis? Y axis is the number. So see, since we are comparing 3 variables, so it's a 3 variable plot, triple variable plot. Okay, now the last chapter is ethics in data science. Okay. Now, let us move onward. So, first of all, why do we need ethics in data science? Why do you think? Well, you see, there are several reasons why we have to adhere to ethical guidelines. You see, guidelines encourage facts, knowledge and error avoidance. Say for example, prohibitions against falsifying, fabricating or misrepresenting data, it promote the truth and minimize error, because there can be someone out there who is trying to fabricate data which is not real, misinterpretation, false data. So, we need to get rid of such scenarios. Okay, so prohibitions are required. You see, ethical guidelines in data analysis also help to build public support for the analysis. Public will say, yeah, this is genuine, this is not fake analysis. People are more likely to confide in the analysis if they can trust data quality and integrity. Otherwise, they will not participate in the survey, they will not give you the primary data. Now, before conducting any new analysis, we ask ourselves whether it will benefit the people. If it does not, we will not do it. Now, minimizing data usage, we should use the least amount of data necessary to meet the desired objective, and understanding that reducing data usage encourages more sustainability and less risky analysis. So, basically what we have learned is that we need to govern data, and this is required to improve data quality through efforts to identify and fix errors in data sets, also to increase analytics accuracy and give decision makers reliable information. You see, governing the data will also ensure compliance with data privacy laws and other regulations. This will help to implement and enforce policies that help to prevent data errors and misusage. Also, governing will avoid inconsistent data in different departments and business units. Also, you see, when you govern the data, you have to come to an agreement on standard data definition for a shared understanding of data. Now, let me give you an example, basic example. When you do a Google search, you get so many pages out there, but on the very first page, why do you think these are the results shown? Suppose the result as what you did the search, when you did the search, there are say overall 1200 web pages. Now, out of this, only the first page 1200 Google search pages, each of them will have different links, each of them. Now, the question is, why is something beyond, why there is something in the first page? The answer is, Google will say the reason is this has been searched by a lot more people, so it gets preference. Now, it is important to know as a student that sometimes this is not the case. Some companies, they give money to Google so that Google can put their reference in earlier when you do some research. When someone does search something, the first result, there is a sort of bidding, and the companies which pay money, they get preference, and then you will see the results from those companies. So, you understand, in a way, the search engine Google, in this case, there has been reports where the search engine is trying to manipulate actual data and trying to effectively take, search engine is taking money from some company, giving preference, and then people by something from that company. So, this should be avoided, and we need governance to avoid such scenario.